recording. Okay, so we're at the end of Dangerous Edition, Sprint 3. So this sprint was 3 weeks long, going from the 13th of February to today, 3/3. As we look at the overview, the number of completed stories is 138, remaining story points is 135, so we're at about 50%. Burn down chart was kind of scary, but my understanding is there was a lot of distraction with MWC, so folks were being pulled over to help with that effort, and that impacted kind of the burn down of the stories that we're committed to. So let's get started on the sprint and what was accomplished. So
Okay,
we'll start.
so
Go ahead, Scott.
sorry, go ahead.
We'll start with Refactor XOS, and Scott, go ahead and go over this.
Sure. So this first slide is on XOS refactoring. So I continued to work on the core API. So some of these were server-side tasks, some were client-side tasks. For the server, we got the token authentication completed. Then we've also added a Tosca endpoint so that we can run our Tosca run our Tosca recipes using gRPC instead of the old REST API. We've developed a core API client. It's based on Chameleon's gRPC client, so it's able to automatically learn the schema by querying the server. It's built as a Python library and installs using the traditional Python setup.py so that any component that needs to talk to XOS can simply install that library and then use it. We finished deploying Chameleon. I think Mateo's now using Chameleon for the REST endpoints for the UI, so that's coming along well. We've also deployed the XOS REST Gateway and XOS GUI components using the new build system. And continuing, started working on refactoring the synchronizers to use the new API. So we've forked off a new synchronizer base class. It's called new_base. It exists in parallel with the old base class until we have fully converted all of the synchronizers over. Then we can deprecate the old one. This base class, it introduces this new shim layer called the model accessor that's used to abstract out any peculiarities of the API. So there is a Django accessor that allows synchronizer to be used with Django. We'll be deprecating that out as soon as everything is converted over. And then there's an API accessor that allows the synchronizer to be used with the gRPC core API. We got one synchronizer converted over to the new base class, and that's the example service synchronizer. By default, when you bring up Code in a Box, you'll get it using the Django API. Right now, there's some manual steps that I can do. There's a new Docker file and Docker Compose that lets you bring it up the new way. And when you bring it up the new way, it'll use gRPC. The advantage of this is we finally got to the point where we could, as soon as we're ready for it, we can fully build the synchronizer containers at build time, and there will be no need to do any building at runtime, and no need to do any rebuilding when the service stack changes. And that's it for this task.
Okay, Sapan?
All right, so the Ansible runner, the new interface between the synchronizers and Ansible is now multi-processed because we were encountering generic threading-related issues, and so we made it multi-process. That's working. We've modified Ansible Helper, which is the main interface between these two things to run playbooks in processes. I spent a lot of time debugging bugs related to this interface. such as having to do with environment variables not getting set or not making it into the Ansible playbooks, and SSH proxy errors, and import issues. So it turns out that imports in Python are not multiprocessing friendly. And lately we've been dealing with a locking issue, trying to diagnose it and pinpoint it with Scott. So that's where we're at with this. Then we instrumented the build system with analytics. I'm going to give a brief demo of that at the end of the session. So previously, in the last sprint, we had instrumented the build system as well as the XOS parts with local analytics that we would use to send log data into ELK stack that we could use to analyze and interrogate a single installation of Chord. This is for multiple installations, so installations that anybody anywhere brings up. And the intent, at least in the short term, is to try to characterize build failures, link them to particular versions of the code or hardware or particular circumstances. And in the medium to long term, it would be to track these errors over time and try and get a metric of the stability of Chord. So right now we've done it only for the build system, but the logical next step would be to also do this for XOS and the synchronizers. So that's it with this task. The XOS IR code generator is getting to a state of functionality. So the parser and intermediate representation is done. We can go back and forth between protobufs and our IR. We have a visitor for translating the IR into template parameters, which we feed into Jinja templates that we can use to generate all sorts of code, such as interface definitions in some other language, such as Yang, for instance, synchronizer stubs, configurations for ELK stack, maybe at a later point, plugins such as forms for the UI, pretty much anything. And I'll give a brief demo of this as well at the end of the session, along with Mixpanel Analytics. So that's it for me.
Okay, thanks, Happen. Matteo?
Yes, in this sprint, we added the build system to platform install to onboard the GUI extension. They can both be built at build time or on a running pod in case if you add a new service. We added the generation of GUI-related configuration files in platform install. And as Scott mentioned, we moved to use the Chameleon REST API instead of the XOS REST API. So we are now able to generate CRUD views for all the models that are loaded in the service at any time, including service models. And we took care of some other small bugs like catching login errors and doing some performance improvements. Basically, because I noticed that there was a race condition when we were connecting through slow internet connection. And that's it.
Thanks, Matteo. Andy?
I spent some time looking into failures in the build process and trying to classify them and look at the relative the rates that specific failures pop up. I was not using Sapin's analytics framework with Mixpanel. I think that will be really useful in the future, but I didn't have access to it when I was doing this. So I was just looking back through the Jenkins code in a box builds and manually pulling out the reason why it failed. So um, several bugs seemed like they popped up more frequently than others, and so I spent some time attacking those and trying to fix them. The ones that I didn't get around to, well, I guess all of them I put in Jira, but some of them got crossed off. The ones that were fixed down at the bottom, I guess there was a issue with mass install hanging. I think we worked around that. Juju add machine. So I don't know. I don't need to go through the list probably, but it seemed like attacking the bugs that popped up most frequently did pay off in that we started seeing the Jenkins code in a box nightly passing much more often than it had previously. So I won't say that every bug is fixed, but I think some progress has been made there. There's some other information on this slide that maybe Sapin wants to talk about with the Elastic Stack.
I think this is actually me.
Okay.
Zach. I changed some of the logging so that we're logging from ONOS and we're logging from Ansible tasks during the playbook runs. So you'll be able to see in Elasticstack as a task runs in Ansible what happens and how that impacts things. For example, you can see the ONOS synchronizer sending a command to ONOS and then the results of that in the ONOS logs all in one place.
Okay.
And that's all in Elasticstack.
Okay. Thanks, Andy and Zach. And then Zach?
Next one was I made Code in a Box run on CloudLab in the Utah branch. CloudLab Wisconsin had some downtime for the last week, and so people were having trouble running stuff on it. So there's a bunch of nodes, so we shouldn't run out of nodes or that shouldn't limit our development process. And those machines are faster. They have NVMe drives, so it reduces the build time by about a quarter to a third.
Okay.
Oh, and so the last thing here is me. So I spent time moving the XOS Docker image build out of the deploy stage up to the build stage. I did not get quite done with that, but I'm at the point where I'm just trying to stamp out a couple of bugs, and then that should be ready to go. As part of that work, I needed to make some changes to how PKI, how the certs are managed. So I guess currently they're being built and saved on the head node, and so I moved that over to the build machine. That's also in progress, but I think it's about done. So these should get wrapped up early in the next sprint.
Okay. Thanks, Andy. Charles?
Okay, so can you refresh the page? I think we have some new information.
One second, it's thinking.
Do we say refresh? Yeah.
Okay.
All right, so the first big feature we implemented during the sprint is the VLAN support in the Fabric, which we've implemented on tag, or sometimes they're also known as access port config. There's a tag mode. Sometimes they're known as trunk port, and native VLAN support. Journal also has a route store to support multiple routes for the SAM prefix. That's for dual only. And Sorok also improved the DHCP Relay app to make it VLAN aware. And you can now resolve DHCP server IP and get the MAC address in VLAN, even when the DHCP server sits behind the gateway router. We also fixed a lot of bugs during the sprint. The first one is we allow pushing MPLS label to a VLAN tagged packet in OVS pipeline. In order to do that, it's a little bit tricky. We need to pop the VLAN, push the MPLS label, and then push back the VLAN again. Anyway. And then the second one is we allow control plane redirect manager to reprogram the flows and groups when the device reconnect. That's because in OTP hardware, we kind of wipe out the flows and groups when the device is gone. So when the device comes back, we reprogram the groups in the correct order so the group chaining will work. And then we've done a lot of testing on IPv6 feature and VLAN features, and also a lot of bug fixing and refactoring. We also fixed some DHCP Relay app bugs. We also done a lot of investigation. So it seems that honest HA bug still persists in the latest Atomics version. We also confirmed an MPLS BOS issue in the Trident2 Tomahawk software that will block the pseudo-wire feature. Basically, the issue is that the BOS 0 flow and BOS 1 flow now need to be installed in a certain order in order to make it work. We already reported this to Broadcom. We also found issues on Chrome. Basically, Chrome doesn't work at all. We also reported that to Broadcom. And we also investigate on how to separate SIM routing app and OTP driver. I've done some local testing yesterday, and it worked pretty well. And we plan to make it effective in Honest 110 and Core whichever release after Dangerous Edition. I plan to do this for next week after all the above-mentioned features and bug fixes are merged. And also I want to wait for Honest 1.9 release because such that I can have a stable version to reference.
Charles, you mentioned the Onos HA bug that was on master and 1.9.
Yeah, I think that's still on 1.9.
Okay, yeah, we keep getting new versions of Atomics.
It seems that the problem is still there. So.
We're getting pretty much daily updates, so we'll have to monitor that then.
Okay.
Okay, thanks. Sujitra, or?
Yeah. So for QA, we completed stories around changes in the platform install repo. We investigated the changes that went into platform install repo, and then we got some inputs from Scott and Baker, like Scott and Zach, regarding the changes, how we need to test and what test cases need to be added there. So we updated and enhanced the existing Jenkins job in order to now the Jenkins job tests all these changes. So we have included the job to test the change sets in 2.0 branch as well, where we are checking for the service profile changes and the XOS repo changes. And then in the master branch, we are checking for the platform install and XOS changes. So that is running fine, and then here and there we find some issues, but some of them are related to Jenkins server itself. Otherwise, all the changes are fine in that area. So we completed these two stories, and there is another story that we created, which is related to the Jenkins job that we want to run on the CIAB install. And this is like a automated QA job where we want to run the test cases against the CIEB, but we are facing some issues in this area, so we are still investigating some of the issues. So that's the update for the QA.
Okay, thanks, Sujitra.
Thanks.
Zach?
So the OpenCloud profile is in progress. I have a OpenCloud in the box script, which is similar to the Cord in the box script, and I'm also wrapping some other work into this, deploying Elasticstack on the head node, which will make it over to Cord in the box eventually. And one of the big changes is this is a topology redesign. So for physical management and a public network with separate segments, it's coming along pretty well. It's just taking a while because we've embedded a whole lot of our Cord isms into the current build process. That's it for that.
Volta? Ali?
Oh, sorry. So we've added persistence and HA to the config store. It's backed by console. Config events are now published to a pub subsystem internally to a single Volta process and as well externally through a Kafka process. Through Kafka, sorry. There's initial support in the core for alarms, which essentially get piped out into whoever wants to, into Kafka and whoever wants to read them. The Maple OLT now publishes stats and alarms. There's been some enhancements to the MicroSemi OLT adapter, basically cleaning up the packet parsing and enhancing the activation process. There's a PMCS ONU adapter now in Volta, which allows us to, will allow us to control a PMC ONU. And also all the documentation is now kept inside the Volta repo under docs directory as a Gitbook. That's all.
Thanks, Ali. eCord?
Yeah, so we onboarded not a new service, but a new person, Francesco. And then the rest of the work really focused on building out the service profile for eCord. So that's, the things that are done there really reflect on building not an rCord service profile, but an actual eCord service profile, along with a few decisions on which XOS commit to base all our work on, because with all the refactoring it's a little tricky to get a stable environment up and running. I think that's about it.
Okay, thanks, Mark. V10?
Is that the answer?
No, this is not
Is it?
on mine.
It's probably
You get another for details.
Really?
Oh,
Oh yeah. The person
Okay.
responsible is probably asleep, so.
Yes. So I think we'll look through it real quick. So V10 API extension, refactored via V10 data model, and API to have a complete set of network state information, added port name on OVS field, added new sync CLIs, updated related wiki pages, and deprecated VSG network type. And then details are in the notes if you guys want more information. And then deployments, Luca?
Yeah, I thought it was useful to start inserting a slide also here. So we deployed a full pod in Calyx, meaning one node to compute nodes for public switches and an additional mass node to reprovision the head node. I've successfully, I believe, deployed Cord 2.0. We discovered just an annoying problem with the QSFP we bought that are not compatible with the Intel cards. So we're just reflashing them. So I'm waiting for the vendor to send me back the cables, which should happen in a week. Anyway, for now we are accessing there with a proprietary VPN client, but the IPsec VPN is in progress with their AT. In the meantime, in QCT, we installed another full cord pod as the one above. Plus, we have 3 additional head nodes, and so in total we have 4 full pods, except that 3 pods miss for now the fabric switches, which will come in 6 weeks. But for now, you can just use 1 full pod and 3 additional head nodes. Also here, I almost succeeded to deploy cord to 0. I finished yesterday. I still see a little bug, but I need to look at that with Andy today. In this case, we have an IPsec VPN ready between us and them. So from your laptop and also from your OLAP VPN, you can access directly to the all the QCT nodes and just provision cord pods. In Flex, I just got in contact with them through Ali, and we need to start to do the IPsec VPN also here and create a Jenkins job to automatically set up the cord pods. Then I just finished to create an IPsec VPN between both our Amazon sites, meaning ONOS and Cord sites, and OLAB. This means that from now, you can access all the machines that are in the lab directly with their private IP from the machines that are in the cloud. So, for example, if we want to connect Jenkins in the cloud to the pod in QCT, just to automate stuff, you can do it just using the private IP of the nodes in QCT. Okay. While doing the deployment work, we found 3 bugs. 1 has been already fixed, 2 are in progress, are assigned to David Bainbridge. I found also some documentation issues, so I'm basically rewriting the documentation. It's work in progress, and I'll share a Google Docs with you as soon as it's ready. That's it.
Just a quick question. Do we have a plan to move our nightly view to remote any of these sites? So we can free our Arco rack right now.
I think are things that are in parallel, right? What you mean free the Arco rack?
So we're running our nightly view using the Arco rack here right now.
Yeah.
Do we plan to move it out to one of these environments such that we can use that rack for daily?
Well, I mean, we can use all these sites for whatever. In some sites, the hardware is shared with, for example, in Calyx, right? It will be on a calendar base. But so the end goal would be to have at least a button in Jenkins for each of these pods, where you can say just reprovision pod, and in one click, well, you need to wait for hours, but it is what it is. You wait for hours, and you have a full pod deployed, wait for you, right? And then if we decide that some of these should be automated during the night, once we have that, for sure, it's just
my point is that we should not, occupy our local rack to do the nightly view. It should be remote.
It's fine. I mean, what do you want to put in the local rack here?
Because I can use that for other purpose for my development. Right now, we basically use the entire rack to do something only run.
Well, we can take this offline. Yeah. I mean, any win is possible in principle, right? I mean, no problems. We don't have any specific plan on that right now, but if it's a requirement, sure. Okay. Any other question? No? Okay. That's it.
Thanks, Luca. So I'm going to close the sprint out after this meeting and then set up the next one. So the next sprint will start on Monday. We'll have a meeting at 2 p.m. to go over that. So start getting your stories in place. The other thing we had talked about is, especially for the refactoring efforts, there's a sprint mapping, so folks can get that updated, and we'll start laying out kind of the plan for the rest of the sprints, especially as we have preparation for ONS and then ONS coming up in the sprint after that. So let's start laying out some of the dependencies. And that's it. I'll stop sharing so that we can do the demo.
Can you see my screen?
Yes.
All right. So we are sending state machine information from the core build process into a service called Mixpanel. Mixpanel is a bit like Google Analytics, if you've seen that. And it can do a lot of the same things. So you can see how many people are doing what over certain periods of time and see them on a map and stuff like that. I'm not going to go into that. So what we get is events across the core build process. Right now it's only the build process, but we will want to add XOS and the synchronizers and services to this at some point. And for any given event, you can segment across a variety of things, such as, say, the last commit for which that that event is being issued out. So this is by last commit, and so you can get a sense of how many users are using what version of your code. The main short-term intent of doing this was to track the success rate of builds. So Mixpanel has this thing called funnels, which lets you track the percentage of events, of executions that move from a certain event to another event. And so here we have the fraction of users that are going from the build starting to it completing successfully. It's abysmally low. I expect that it's getting reduced by the fact that a lot of people are testing their patches. And also this data right now is polluted by early test cases when this stuff wasn't really working. So when we add an indicator of whether a person is using an experimental patch or master, then hopefully they should improve. But yeah, so what we see is a success rate of 6%. We can segment it by things like, again, the last commit or the machine on which the build's running on. So for instance, looking at the domain name where these builds are coming from, we can break up the success rate across the various clusters on Cloud Lab. And so Zach made this observation that builds on Utah finish faster. And so that's again a stat that can be verified. Again, we don't have a lot of data, just 2 successful builds registered via Utah. But it does show that it's taking a little bit less time than Clemson. And besides the overall build, we can also say check the success rate of the Vagrant VMs coming up. We're doing pretty well in that department. Install head node, a bit better, close to 50%. End-to-end tests succeeding, pretty low. So these are things that we can hopefully track over time, not only to identify and fix bugs, but also to have a an overall metric for the stability of the build process, and later on for XOS, the synchronizers and services as well. So I can click on this eye and get a profile of the stability across days, weeks, months.
Okay.
And lastly,
Sapan, can I ask a question? Why did you take this tool and not publish these metrics into Jenkins directly, since Jenkins is doing builds anyway? It's doing the code in the box build, it's doing the nightly hardware build. So why have this different tool here?
So no particular reason for that. I don't think it would have taken any more time for. So does Jenkins give you funnels?
Yeah, I don't know. I mean, I guess I don't know what a funnel is. Yeah, sure. It gives me a funnel.
Yeah. So I guess what I had in mind was certain functionalities, certain benefits and metrics that we'd like to track, and I was sure that this Mixpanel tool, gives us those functionalities and metrics, and so I opted for that. If Jenkins gives us the same thing, the same metrics, and it's convenient. Oh, so by the way, this tracks builds that people run on their own hardware, without.
So if I run it on my laptop, how does it know that I built something? If it's Pi?
Beg your pardon?
How does it know, like if I do a build on my laptop, how does it know that I did a build on my laptop?
Well, as long as you're connected to the internet, I guess.
So maybe something that we should clarify. I think this is only for Cord in a Box, right? It's only if you run the Cord in a Box script, and that's been instrumented with the Mixpanel stuff. So it probably is not going to happen on your laptop, Ali. You won't get metrics.
Okay.
Right, and so lastly, and again, this was one of the main points of going through this exercise, is that if a build fails, so finish event with status set to something other than 0, then you can actually segment by, it takes a snapshot of the install log file and tries to figure out the set of errors that come out of that and register those. And so you can actually, you get a comprehensive list of the errors that are happening, and you can see frequencies of those errors, how often they're happening. Again, segment further by machines and so on. So anyway, so we have this facility. It gives us a certain amount of information, and it was pretty easy to implement. Mixpanel is a nice tool, it's free. And if you want to switch over to something else, then that should not be a problem. So while I have your attention, I have the screen. I'm going to show you the...
Sapan, one quick question. Can you publish the URL for this? I'd like to try it out.
Okay.
Do we need a login for it, or is it available publicly to everyone, or what do we need to do?
I need to send somebody I need to send out an invite to whoever would like to look at this data.
Okay, great. Yeah, please send one.
Okay.
I think Sapan, I mean, this is fine for, I guess, for Cord in a Box, but I think ultimately the goal is that instrumentation is not in a script wrapping and install of the process. The instrumentation is an integral part of things coming up or not coming up. So what I mean by that is your containers have facilities that indicate whether they came up correctly, and if not, why not, right? and these things are published into some database or some key value store or something, right? But that's the whole idea. If you instrument externally, then anybody not using that tool loses those metrics, loses that information. And this kind of information, I mean, I guess maybe for the build it's debatable, but this kind of information is not only useful at install time, it's useful at runtime. So at runtime, you want to be able to tell which ones of my services, which ones of my containers, which ones of my processes are up and running, are they okay, are they not okay, and so on. And I should be able to run validation against those components.
Right. So two observations there. First, this is not a data archiving and gathering service. It's an analytics service. So the main thing, really, the main value of this this facility is, the graphs, the UIs, the nice widgets that let you analyze this information. And I hadn't planned ahead of time that you'd be able to see how much time a build takes to complete and segment that by. But I was able to validate Zach's assertion that Utah's better. That's the first observation. The second observation is that here, so the metrics that we evaluate here and that we're using here are not operator metrics. It's not for people who operate an infrastructure. It's developer metrics. It's for us as software developers to get a sense of what the stability characteristics of our software stack are. So we have the pod in a box environment, which is a whole lot of scripts and configuration routines, and of course XOS and the services that come up. And we'd like to evaluate the stability of that for anybody who brings it up, in some context.
So the point, I guess my point, in response to what you're saying, is that the metrics that you're talking about, there's no difference between developer and operator metrics. They're the same metrics. The point I'm trying to make is,
so these are across operators. These are across, everyone who's trying these. So for
I understand that, and I understand that particular use case. I'm just trying to make an overarching point that, think about when you instrument something, think about instrumenting it in a generic fashion such that any other tool can consume this information, right? If you were to publish your metrics in a kind of structured fashion, then any tool could lay over it, and no one would care what tool you're using because they can use their tool. That's kind of the overarching point I'm making, but I mean, that's fine.
Yeah. So we have, so with the Elk Stack setup, we're using Logstash and some sister tools, and then that goes off to something, Elasticstack, but it may as well go elsewhere. And we use Kibana, but we might use some other visualization tool too. And this could have been placed on that chain of tools along somewhere. It could be plugged into that network of tools. I spent 3 days or something like that putting this together. I count that as part of future work of making it generic in a way that it's modular, so that you don't have to buy into the whole setup. You can put things together piecewise. Anyway, I'm going to quickly I don't know if you have time. Maybe it'll take another few minutes to demo the IR. I don't have to do it now. I could also do it in the TST meeting if you're running out of time.
No, we still have about 10 minutes.
Okay, so the IR, as mentioned before, is an IR in general is a mapping between a source language and a target language that enables you to transition from one to the other. That's the implementation part, but formally speaking, it also lets you put bounds on, formally understand and document what your target languages are and what you're trying to generate. So we've chosen protobufs, or the syntax and grammar of protobufs, as the language we're going to use to specify XOS data models. We've also augmented it with some things that XOS needs, or augmented the semantics, like certain attributes for fields, and the ability to link models. And so the way this works is that we're able to parse protobufs files and turn it into this intermediate representation, and then pass a lightweight version of that representation into Jinja templates, which enable us to generate whatever pieces of our functionality and software that we need. And so here I have a simple proto file. I have a tool called, it's Uber input proto2, and I'm going to pass it to a template called proto.xtarget, which is a Jinja template. It just serializes the protobus format. And so what it's done, it's essentially parsed it into the IR and serialized it. So we've augmented the protobufs syntax, and we've added semantics to it, and there's a sugared version of that, and that you can see in this file. So the new thing is this one-to-one mapping, which goes from a field in the current message into a field in a different message. And so we're going to pass this as well. We're going to pass that as input, and we can pass it into the protobufs pretty printer. And so what it does now is it parsed the intermediate representation, the sugared version, in which the XOS extensions were made explicit in a way that if you type them out wrong, then you get a syntax error or something like that. And it turned it into native protobufs representation. So putting the link information, the fact that this first field is a link in the protobufs options. You can do the same reverse transformation. And the protobufs target serializer, the pretty printer, looks like this. It's a Jinja template. And so the next steps here are sort of cleaning up the implementation a bit, writing templates for Django, for synchronizer stubs, and for anything else that we need, so that we can start using protobufs as the main source format for specifying data models. That's it for this demo.
Any questions, comments? Okay, thanks, Apan. Just a reminder, I'm closing out the sprint after this meeting, so thanks everyone, and please prepare for the planning session on Monday. Thanks. Bye.
Bye.